In this class, I'll discuss with you some problems related to the Kirchhoff's second law. Okay, now listen, ma. So one circuit diagram here I'm taking. This is A, B, and C. Now here this is the 5 volt given in the problem, and this is the 5 ohm, 5 ohm, 1 ohm. This is the 3 volt. Draw the circuit, ma. And 6 volt, and again 3 ohm. Current is passing like this. This is the I is the current moving like this. Here we need to calculate in the problem given that calculate current passing through the circuit. I value we need to calculate. I value. Apply the Kirchhoff's second law. By applying the Kirchhoff's second law, here I am taking the loop from A, B, C, A loop. From A, B, C, A loop. So from this loop here I am taking A, B, C, A. At first move from A to B, negative terminal, and this is the positive terminal, low to high, 5 plus 5, and then you are moving A to B, current also in the same direction, both are in the same direction. Current passing through this current passing through the 5 ohm resistor is I only. So according to Ohm's law, both are in the same direction, potential difference is negative, resistance is 5 and current is I, 5I, and then move like this. The same current is passing through 1 ohm resistor also. You are moving B to C in the same direction, current also following, and that's why minus 1 into I, minus I, and again high potential to low potential, minus 3, and then again you are moving from C to A in this branch, low to high means high only, plus 6, and same current I passing through the 3 ohm resistor also. Why? Because the current is moving like this. There is no change in the path of the current. So everything is in series combination. Now 3 into I, 3I, both are in the same direction and reach the point A, and finally that is equal to 0. That's equal to 0. Now 5 minus 6I minus 3 plus 6 plus 3 minus 3I is equal to 0. 5 plus 3, 8, minus 6 minus 3 minus 9I equal to 0. 9I is equal to 8, minus 9I plus 9I avutundi, is equal to 8. I is equal to what's the value? 8 by 9 ampere. 8 by 9 ampere. The potential difference between the points A and B is, and this is the point A, positive terminal, negative terminal, two ohm resistor, this is 5 volt, and this is given that 2 volt and 1 ohm. This is point B. Current is 1 ampere. Here current is moving from A to B. Apply the Kirchhoff's second law. From where the current is started, that is the positive end, the other end is a negative. Other end is a negative. So at A, the potential is positive plus VA. Now move in this direction. At first you got the positive end of the term battery, negative end of the battery. Positive to negative, high potential to low potential, minus 2. Same current is passing in this direction. You are moving in this direction, current also in the same direction. So the potential difference is negative. Current into resistance, 2 into 1, 2. These all are in series combination. So same current 1 ampere is passing between A and B. Between A and B. So here minus 2 into 1 minus 2. Again negative to positive, low potential to high potential, plus 5. And in the same direction, current is passing in this direction, I. That I is nothing but 1 ampere here. Both are in the same direction. You are moving from A to B, the current also in the A to B. So IR 1 into 1 minus 1, and this is the negative end, minus VB is equal to 0. Now VA minus 2 minus 2 minus 4 and minus 1 minus 5. This is plus 5. Minus VB is equal to 0. Now minus 5 plus 5 get cancelled. VA minus VB is equal to 0. So that is answer is 0 volt. Answer is 0 volt. Another problem here. This is a new circuit again. 5 ohm, R ohm, this is P. This both the ends, this entire part is Q. This is R and this is S. According to here the question is, to balance the bridge in the circuit, the value of R is. So you want to take this as a balanced Wheatstone bridge. What is the value of R? Now here observe, balanced Wheatstone bridge condition, P by Q equal to R by S. Now P is nothing but 5 ohm. Q is nothing but, these two are in series combination. 12 ohm and R both are in series. So Q is nothing but need to add these two resistors, 12 plus R. Why? Because these two are in series combination, is equal to R 15, S 60. 15 ones are 15 fours are. Now 5 by 12 plus R is equal to 1 by 4. 4 fives are 20 is equal to 12 plus R. Then R is equal to, take this 12 to this side, minus 12. 12 minus 12 is equal to 8 ohm. It means if you connect 8 ohm in the place of R, then the bridge is balanced. Okay, that is the question. And R equal to 8 ohm is the answer. And see this circuit diagram. And I'm taking the question here. I'm taking the question. In the circuit of figure, with a steady current, the potential drop across the capacitor is. Across the capacitor, I need to take the potential drop. So across the capacitor, the potential drop here, I'm taking that VC. I'm taking it as VC. So first, here I'm taking that, I'm applying the Kirchhoff's second law for this. For that, I'm naming the loop here, A, B, C, D, E, and this is F. A, B, C, D, E, F. I'm taking the loop. Okay, now listen clearly, ma. At first, I'm taking the upper loop in this direction. So I'm taking the loop from loop A, B, C, F, A. A, B, C, F, A. This loop I considered. At first, I am going from A to B. A to B, I am moving here in this direction. Anyway, positive terminal is here. Current is considered like this. Current is taken like this. Okay, so low to high, low to high, low to high is nothing but plus V, positive potential, and you are moving in this direction. Current also in the same direction, minus I into R, negative sign, and come to B to C, no cell and no resistor, nothing. And then from C to F, this end is connected to negative and this end is positive. Why? Because this is the positive end. So plus is connected, this is minus. Minus to plus, plus VC, and then high to low, minus V, and F to A again, no cell, nothing. You started from A, ended at A. So finally, that value equal to 0. Plus V and minus V get cancelled. Then minus IR plus VC equal to 0. Then VC is equal to minus IR, send that side, plus IR. Minus IR, send that side, that is plus IR. Okay, now this is one equation. I consider this is one. I am taking another loop, so that another loop is like this. So in this loop, if you observe, I am taking that from loop A, B, D, E, A. A, B, D, E, A. So in this loop here, it's very clear. It's very clear, ma. That is AB, first AB, low to high, plus V. Same direction you are moving. Current also in the same direction, minus IR. B to D, nothing is present. D to E, D to E. So here I consider that the same to IR. This is the negative to positive terminal, current is moving like this. Positive terminal, current is moving like this. Otherwise, yeah. So I'm giving one more way here itself. Just now I got the idea, and that is, in the case of steady current, the capacitor is fully charged. So there is no passage of the flow of charges through the capacitor. So this can be invalid. The CF branch can be invalid. Once a CF branch can be invalid, then we used to take, this is now not present in the circuit. At that moment, I need to take current. Current I is equal to. So here in the circuit, in the steady state, no charge flow in the capacitor. So I'm removing that. This is the circuit right now. In this case, just observe carefully. This is only the circuit here. This R and 2R both are in series combination. So net resistance, total resistance is 3R, R plus 2R, 3R. And this negative terminal, see here, connected to negative terminal. Negative connected. So net potential is 2V minus V. Negative to negative connected. So 2V minus V. Then I is equal to V by 3R. V by 3R. Now I'm taking that IR. This R take this side. IR is equal to what's the value? V by 3. So from the first equation, VC is equal to what? IR. So in the place of IR, I'm writing VC. VC is equal to what's the value, ma? V by 3. The question is, what is the potential difference? What is the potential difference across this capacitor? the capacitor, across the capacitor, the potential difference is Vc, then Vc is equal to what's the value, ma? V by 3. Vc is equal to V by 3.